Hi, welcome back to Mr. Wernau Does Your Homework. So today we're going to take a look at question number 10 from Power Series Day 3 worksheet. And the question here says we're given a Taylor series centered around x equals 3. And we're told that it converges for all x in the interval of convergence. That's going to come back to haunt us in just a few moments. We're going to pay attention to that. And then they tell us how to get the nth derivative. So remember, this all comes from Taylor, and Taylor polynomial says we're going to get f, the nth derivative at some center over n factorial x minus c to the n. What they're giving us is just the top of Taylor. So we want to find a fourth degree Taylor polynomial, so which means we would need the fourth derivative. So we're going to start off with the, let me write this in black. The value of the zeroth derivative, I'm just going to plug it into our function that they give us. Remember, this is giving us the value of the derivative, of the nth derivative. Plugging in the 0, we get negative 1 to the 0, which is 1. 0 factorial, which is 1. 5 to the 0, which is 1, times 4. And this becomes 1/4. Keep going. Just ignore that. Get the value of the first derivative, same thing. We're going to plug it into here. And this becomes negative 1 to the first, which is negative 1. 1 factorial, which is 1. 5 to the first, which is 5. And 1 plus 3, which is 4. So we get negative 1 over 20. And to get the value of the second derivative, same idea. We're going to plug the 2 in now. And that's going to give us negative 1 squared, which is 1. 2 factorial, which is 2. And this becomes 5 squared, which is 25, times, and 2 plus 3, which is 5. And simplifying that, that's just 2 over, whoops, messed that up, 2 over 125. Getting the value of the third derivative. And for the third derivative, I'm not really going to simplify too much. When I plug this in, we're going to get negative 1 times 3 factorial over 5 to the third, which is 125 times 6, whatever that is. We're still not done because we still need the value of the fourth derivative. To get the value of the fourth derivative, same thing, we're going to plug it in. That's going to give us 1 times 4 factorial over 5 to the fourth, don't know what that is, so, and times 7. So to write our Taylor polynomial of degree 4, we are going to get, centered around x equals 3 again, we're going to get 1/4 minus 1 over 20. Remember, this is over 1 factorial, so I just take that bottom and divide it by 1 factorial. X minus 3 to the first. The next one, we would get plus 2 over 125. We're going to put that over 2 factorial, so I just divide that by 2 factorial. X minus 3 squared. And then plus, oops, sorry, not plus, but minus, the top here becomes 1 times 3 factorial over 125 times 6, but we're going to put that over 3 factorial, so I can just divide that by 3 factorial again. X minus 3 cubed, and then the last one plus 1, basically, I guess 4 factorial over 5 to the 4th times 7. And again, this is going to go over 4 factorial, x minus 3 to the 4th. And there is our polynomial. Now, if you're really good and you notice some things, these will all cancel out. 2 factorial is there, the 3 factorial will cancel, the 4 factorial will become that. And if you clean this up, our final polynomial will become 1/4. This becomes minus 1 over 20, x minus 3, plus 1 over 125, x minus 3 squared, minus 1 over 125 times 6, x minus 3 cubed, minus 1 over 5 to the 4th times 7, x minus 3 to the 4th. You don't have to clean it up, but it does help make it look nicer. All right, for part B, now they want us to find the radius of convergence. So for this one, we will need our general term. To get the general term, That's just going to be this negative 1 to the n factorial, over 5 to the n plus 3. Now that's, remember, this is just the top of my Taylor polynomial here. So I would have to divide this by n factorial. So I can just put that on the bottom, and this becomes x minus 3 to the n. And of course, the factorials cancel, which is nice. And now we're going to use our ratio test, the limit as n goes to forever. Again, since we're using the ratio test, we don't have to worry about the alternating part. It's just going to become positive, and we get this x minus 3 to the n plus 1 over 5 to the n plus 1 times n plus 4. Flip and multiply, we're going to get 5 to the n plus 3 over x minus 3 to the n. And that's going to have to be less than 1. Cleaning this up a little bit, we would get this x minus 3 on top times n plus 3, and on bottom, we would just get 5, and this n plus 4. The ratio there is less than 1 for right here. And then we can just use a little bit of algebra to solve this. Factor out anything that does not have an n to it, and that's going to give me this x minus 3 over 5 times the limit as n goes to forever of n plus 3 over n plus 4. See how exciting this is? That's going to be less than 1. And that's going to give me the absolute value of x minus 3 over 5 is less than 1. So now I can take a look. My center is x equals 3. My radius, we can now solve that over here. We can get our radius, and that's going to be the absolute value of x minus 3 is less than 5. So our radius here will be 5. And now all we have to do is get the interval. And this is where the fun begins, because we have to now check our endpoints. Checking the endpoints, the first, so when we got that absolute value of x minus 3 is less than 5, if we were to solve it, x is going to be between negative 2 and 8. Oops, I said equal to 8, not equal to 8 yet. So I'm going to check x equals negative 2. Plug it into our general term. Remember, it's negative 1 to the n. And if I plug the negative 2 into my x minus 3, that's going to give me negative 5. Negative 5 to the n over 5 to the n times n plus 3. The 5 to the n's will cancel, but this will leave us with a negative 1 to the n. So our new series looks like this. It'll just be n, because that negative 1 to the n times negative 1 to the n is negative 1 to the 2n, which is positive. I'm going to make it even. So that's going to become 1 over n plus 3. This is our comparison. I'm going to compare it to b sub n. So this is p equals 1, so therefore this will diverge by p series. And I'm going to use limit comparison here. So if I take the limit as n goes to forever, this becomes 1 over n plus 3 times n over 1. That's going to equal 1, which is finite and positive. So therefore, this will diverge by limit comparison. So simply put, x can't equal negative 2. Now the last one we have to pick is x equals 8. And this one works out a little bit nicer. If I go from 0 to infinity, it's still got the negative 1 to the n. And if we plug the 8 into our x, we're going to get 5 to the n over 5 to the n times n plus 3. Those cancel. This is now an alternating series, so the series alternates, decreases in magnitude, and the limit equals 0. Therefore, this will converge by alternating series. All right. So we can use 8. We can't use negative 2. So our interval, this is a long one, will go from negative 2 to 8, but we will include 8. Now, on the AP, this is worth a lot of points. You hope for one of these. It's not hard. It is lengthy, but it is worth a lot of points. All right, for part C, now they say show that the third degree Taylor we got from part A can approximate the value of 4 with an error of less than 1 over 4,000. So from part A, I'm going to use my fourth degree Taylor polynomial, which is p sub 4 of 4. I'm going to plug in 4. And if we did that, remember, we're using our polynomial up here. My first term is going to be 1/4. Minus, this becomes 1 over 20. And when you plug the 4 in, 4 minus 3 is just 1. So that's all of them. So the next one's going to become plus 1 over 125. The next one is minus 1 over 125 times 6. Now remember, this should be a third degree Taylor polynomial. So there it is. There's my sum right there. So just remember, this was degree 0, that was degree 3. Now we want to show that it is less than, has an error of less than 1 over 4,000. This is an alternating series, so we could say that the series alternates, decreases in magnitude, and the limit equals 0. Therefore, the error in the third term is less than the fourth term, which we found already. The fourth term was up here. That was this 1 over 5 to the fourth times 7. And I'm just going to plug it in. This is just 1 over 5 to the fourth times 7. And remember, it is 4 minus 3 to the fourth. But again, that's just 1. We don't have to worry about that. And the question is that less than 1 over 4,000? And the answer is yes. They're not going to make you prove this in AP, but it is less than 1 over 4,000. And this is going to become by alternating series remainder. This is big on the AP. And there's your answer right there. Don't forget to mention the mantra. The series alternates, decreases in magnitude, and the limit is 0 first. All right, well, that's question number 10. I hope you guys enjoyed the video. Smash that like button, subscribe, send it to your neighbors. Thanks.